welcome to the channel of Digital to Real. Today we are going to discuss about memory refresh of DRAM. DRAM के memory refresh के बारे में हम discuss करेंगे. जो DRAM होता है that only is the main memory of the computer. Okay? जहाँ पे regular interval में हम memory को refresh करते हैं जिससे कि जो information once read उसकी वजह से already available जो इंफॉर्मेशन है वो डिस्ट्रॉय हो जाता है, उसको डिस्ट्रॉय ना करके उसको प्रिजर्व करने की कोशिश की जाए. सो दैट इज व्हाट हैपेंस इन मेमोरी रिफ्रेश ऑन ए रेगुलर इंटरवल ऑफ टाइम. सो रेगुलर इंटरवल ऑफ टाइम में एन एरिया फ्रॉम कंप्यूटर मेमोरी का एरिया हम रीड करते हैं, वी रीड इट, ओके, एंड वी इमीडिएटली रीराइट द सेम एरिया विद द सेम रेड इंफॉर्मेशन, ओके, for the purpose of preserving the information without loss. So whatever the area we read it, we again rewrite it with the same read information. Why do we use it? So that while reading the data, if the information has got lost, it should not get lost. Rather, we should rewrite the same data into the memory. So in this way, we preserve the information. So it is a maintenance process required in DRAM, which is mainly used in computer memory. So this memory refresh is actually a maintenance process. ये एक maintenance process है जो DRAM में होता है along with the read and write operation. ठीक है, जिससे कि जो information हम read करते हैं उसकी वजह से जो already available data होता है वो destroy ना हो जाए reading process में. उसके लिए हम ये एक process का use करते हैं memory refresh DRAM में, और एक maintenance process है. In DRAM, each bit of memory data is stored as a presence or absence of an electric charge on a small capacitor on the chip. So DRAM में information कैसे store होता है? हर एक bit of information store होता है एक capacitor में, okay? A presence or absence of electric charge. capacitor में presence या presence होने से bit information is 1, absence होने से bit information is 0. So the presence or absence of electric charge on a small capacitor on the chip, that only decides whether the information stored is 1 or 0. So what happens with due course of time, जो information store होता है capacitor में, जो charge store होता है वो leak होता है. Leak होने के कारण क्या होता है? Information loss होता है. As time passes, the charges in the memory cells leak away. So विदाउट बीइंग रिफ्रेश, अगर हम इंफॉर्मेशन को रेगुलर इंटरवल ऑफ टाइम में रिफ्रेश नहीं करें तो इंफॉर्मेशन क्या लॉस हो जाएगा, बिकॉज इट विल लीक अवे. सो विदाउट बीइंग रिफ्रेश द स्टोर्ड डेटा वुड इवेंचुअली बी लॉस. सो एक्सटर्नल सर्किटरी इज यूज्ड टू पीरियोडिकली रीड ईच सेल एंड रीराइट इट. सो रेगुलर इंटरवल ऑफ इन टाइम में रिफ्रेश करने के लिए, सो दैट द डेटा विच इज देयर इन द मेमोरी and it is not lost while reading, in order to do so we have external circuitry, okay, hence restoring the charge on the capacitor to the original level. So what actually the external circuitry does, it restore the charge on the capacitor if it is 1 to the original level. अब refresh cycle में होता क्या है? What happens in refresh cycle? When we do the refresh cycle, at that time we don't do the normal read and write operation. So, while a refresh cycle is occurring, the memory is not available for read and write operation. But in modern memory, this overhead time is not large enough to significantly slow down memory operation. That means what? Means the refresh cycle should happen very fast. What happens in refresh cycle? So, refresh cycle में होता क्या है? So, actual refresh cycle में क्या होता है कि memory जो normal read and write operation के लिए available नहीं होती है. So, हम ऐसा सोचेंगे then read and this refresh cycle take lot of time. No, it is very fast, so that it doesn't add too much overhead on the time that is needed in order to access the memory for read and write. So while a refresh cycle is occurring, memory is not available for read and write operation. That is what I said. refresh cycle में आपका memory read and operation के लिए available नहीं होता. But in modern memory में this overhead time is not large enough to significantly slow down the memory operation. So modern memory में ये read and ये refresh cycle के लिए जो time लगता है that is not very large. Okay, and that is the reason that it doesn't slow down the memory operation. Memory का operation क्या है? Basic operation is read and write. So because of this refresh cycle, there is not much delay in memory operation. In DRAM, memory chip is laid out in rectangular array of rows and columns. In DRAM, memory chip is laid out in a rectangular array of rows and columns. So DRAM is arranged in rows and columns. The read process in DRAM is destructive. Actually जो read process है DRAM में, DRAM किससे बना है? कैपेसिटर से बना है. उसमें इंफॉर्मेशन कैसे स्टोर होता है? चार्ज के रूप में. So charge when it is available, that means bit 1. When charge is not available, that means is bit 0. And this read process in DRAM is destructive in nature. It removes the charge on the memory cell in the entire row. तो ये क्या करता है? आपका चार्ज रिमूव करता है मेमोरी सेल में. सो देयर इज अ रो ऑफ स्पेशलाइज्ड लैचेस ऑन द चिप कॉल्ड सेंस एम्पलीफायर. इसलिए एक रो के लिए आपका क्या है? सेंस एम्पलीफायर अवेलेबल है. ओके, और सेंस एम्पलीफायर किसके लिए अवेलेबल है? हर एक रो में जो आपके कॉलम बिट्स के लिए आपका सेंस एम्पलीफायर अवेलेबल है. वन फॉर ईच कॉलम ऑफ मेमोरी सेल to temporarily hold the data. Why the sense amplifier is there? Because the reading process is destructive in nature in DRAM. Hence, we have the sense amplifier in order to not let the data to be destroyed, in order to hold the data temporarily. Refresh cycle is similar to the read cycle. Refresh cycle कैसा है? ये read cycle जैसा ही है, but it executes faster for two reasons. पर ये रीड साइकिल से फास्ट है. पर क्यों है वो देखते हैं. देयर आर टू रीजंस फॉर दैट. फर्स्ट रीजन, फॉर ए रिफ्रेश only the row address is needed, as a column address doesn't have to be applied to the chip address circuit. So आपका जो रो एड्रेस ही चाहिए होता है in order to have a refresh. ओके, हमें कॉलम एड्रेस की ज़रूरत नहीं होती. सेकेंड, डेटा रेड फ्रॉम द सेल डज नॉट नीड टू बी फेड इनटू द, क्योंकि यहाँ पे जो हम डेटा रीड करते हैं that is not for sending it out on the data bus. Rather, this is a maintenance process. So the data read from the cell does not need to be fed into the output buffer. हमें output buffer में भेजने की ज़रूरत नहीं होती. Or the data bus to send to the CPU. इसका रीज़न क्या है? क्योंकि ये एक रिफ्रेश जो साइकिल है, ये एक मेंटेनेंस प्रोसेस है. इट इज़ नॉट द यूजुअल रीड प्रोसेस. Usually, refresh circuitry of a DRAM consists of a refresh counter which counts the address of the row to be refreshed. यहाँ पे हम जब रिफ्रेश करते हैं हम रो एड्रेस प्रोवाइड करते हैं, कॉलम एड्रेस नहीं प्रोवाइड करते. एंटायर रो को एक ही बार में रिफ्रेश करते हैं. सो हमारे पास एक काउंटर होता है, रिफ्रेश काउंटर, जो काउंट करता है. ओके, फर्स्ट रो इज रिफ्रेश, ओके सेकेंड रो इज रिफ्रेश. सो वी कीप ऑन इंक्रीमेंटिंग द काउंटर in order to make sure the whole of the memory has been refreshed in due course of time. Two scheduling strategies have been used. So refresh operation के लिए two scheduling strategies है. The way in which the refresh counter is incremented, how we make sure that the whole of the memory has got refreshed. So in order to do so, we have two scheduling mechanism or scheduling strategies. First one is burst refresh. A series of refresh cycles are performed one after another until all the rows have been refreshed, after which normal memory access occur until the next refresh is required. यहाँ पे क्या है? burst refresh में पहले हम पूरा का पूरा memory refresh कर लेते हैं. We go through first refreshing first row, then refreshing second row, then refreshing third row. So we keep on incrementing the refresh counter to make sure the whole of the memory has been refreshed, and then only we do the normal memory access. That is the burst refresh. Second one is the distributed refresh. Refresh cycle are performed at regular intervals and interspersed with memory accesses. यहाँ पे in distributed refresh, the refresh cycle is not separate from the memory read and write cycle. We do not have a distinct line. Rather, they are interspersed. Means first two rows might be refreshed. Then we doing the read and write operation. Then next two rows are getting refreshed. Then read and write operation. So refresh cycle are performed at regular intervals interspersed with memory accesses. In distributed refresh, the interval between refresh cycle is refresh cycle interval is equal to refresh time divided by the number of rows. पूरा रिफ्रेश करने के लिए मेमोरी को, मतलब हर एक रोज को, पूरे के पूरे सारे रो को रिफ्रेश करने के लिए जितना टाइम लगता है उसको कहते हैं रिफ्रेश टाइम, डिवाइडेड बाय नंबर ऑफ रोज. जब हमें पता चलेगा उस समय पता चलेगा रिफ्रेश साइकिल इंटरवल क्या है. मीन्स इन ऑर्डर टू रिफ्रेश अ पर्टिकुलर रो what is the time required, that is called the refresh cycle interval. Refresh time or refresh time is the whole, in order to refresh all the rows, what is the time required, that is the refresh time and the number of rows. Now we are having an example. For example, DDR SDRAM has a refresh time of 64 milliseconds and 8192 rows. So refresh cycle interval is, अच्छा, रिफ्रेश करने के लिए एक रो को रिफ्रेश करने के लिए कितना टाइम लगता है. रिफ्रेश साइकिल इंटरवल इज, पूरा रिफ्रेश टाइम कितना है आपका 64 मिली सेकेंड. और आपके SD RAM में कितने रोज है 8192 रोज. अगर 64 मिली सेकेंड डिवाइडेड बाई 8192 रो इफ आई डू, देन व्हाट इज द टाइम रिक्वायर्ड इन ऑर्डर टू रिफ्रेश अ सिंगल रो, दैट इज 7.8 माइक्रोसेकेंड. So the refresh time, that is the time required to refresh all the rows. Now in distributed refreshing, what we have the read and write operation and refreshing operation, that is interburst. Okay, so now we will see the refresh overhead, means the total time that is needed for refreshing and for read and write cycle. Okay, that is the total time, and refresh overhead is what is the percentage of the time in the total time is needed for the refreshing operation. That means how much overhead it add to the normal read and write operations, means what is the time due overhead it add to the time it taken to the normal read and write operation. So refresh overhead, the fraction of time the memory spent on refresh, the refresh overhead can be calculated from system timing. So you have the refresh overhead, how you calculate it is equal to time required for refresh divided by the refresh cycle. Refresh cycle में क्या है, you have the total time for refreshing and the memory read and write. So what is the refresh overhead, time required for refresh divided by refresh interval. For example, on a SDRAM chip, suppose SDRAM chip has 2^13 rows, that is 8192 rows. A refresh interval of 64 millisecond. आपके पास refresh interval कितना है 64 millisecond, means the total time needed for refresh all the rows. The memory bus runs at 130 megahertz speed. So memory bus runs at what speed? 133 megahertz, and the refresh cycle takes 4 clock cycle. In order to refresh one row, we need 4 clock cycle. The time needed for refresh cycle is, तो refresh cycle को मैं कैसे find करूँगी? 4 clock cycle. What is the 1 clock cycle period? That is 1 divided by 133 megahertz. Then I will get the 1 clock cycle. Then 4 clock cycle is the refresh cycle. In order to refresh a single row, I need 30 nanosecond. Now the time needed for refresh is that in order to refresh all the rows is length of the refresh cycle multiplied by number of rows, that is 0.246 millisecond. 30 nanosecond for 1 multiplied by 8192. Now what is the refresh overhead? Refresh overhead is what is the refresh interval, overhead on the refresh interval. So the refresh interval includes for refreshing purpose time plus the read and write operation time also. So 0.246 millisecond divided by 64 millisecond. 0.246 millisecond is this one time taken for refresh, divided by total time that the refresh interval, that is for refreshing and normal read and write, that is 64 millisecond. This is actually for that is for distributed refreshing scheduling operation, where we do the refreshing, then also we do the memory read and write. So there is not distinct difference between the two. Means we do not make sure that the refresh operation is finished and then only we are doing the memory read and write operation, but they are interspersed. So this refresh overhead is 0.246 millisecond divided by 64 millisecond, and that is coming as 0.0038. So you multiply by 100, then you will get 0.38, that is less than 0.4% of memory chips time will be taken for refresh cycle. So hope I am able to make you understand about the DRAM memory refresh operation. Okay, if you like the video, please share with your friends. Please subscribe the channel. Have a nice day. Bye bye.